This is the instructional lesson for volume of pyramids and cones 7.02. We'll start with the volume of a pyramid, and you will probably notice that a pyramid kind of has a similar base shape to some of the prisms that we worked with in our lesson from 7.01. But as the pyramid rises in height, it does not maintain that same congruent shape all the way to the top of the pyramid. So what happens is you start with a base shape, and then as the pyramid increases in height, that base shape is a similar shape, but it is not a congruent shape. So if I start out with, let's say, a rectangle as the base of my pyramid, as the pyramid gets taller, that rectangle is going to be similar to the base, but not congruent, because it is going to get smaller as we go up. In other words, as well, the cross section is going to get smaller as the pyramid increases in height. Your formula for volume to compensate for this decrease in our cross section, we are going to find the volume by multiplying the area of the base times the height, but then we are also going to multiply that by 1/3. So essentially a pyramid is going to be 1/3 of the volume of a prism with the same base. Let's take a look at some examples. We're going to kind of talk through these. You can see that they are worked out for you if you need to pause the video so that you can fill everything in and take a look at the different processes and computations, then that is fine. The first one on the left is a rectangular pyramid. And so the base that we get is a rectangle. What I have done is I have drawn out the base shape in green here. So this is our rectangular base. I've also identified the actual height of the pyramid. So the height of the pyramid is going to be perpendicular to the base. So you can see right in here, we have a right angle measurement on the inside of that pyramid. And it is going to drop from that tallest point, which at the very top there is they've given us is 16 inches. So we're going to drop it from that top point, and we're going to drop a perpendicular down to the base of the pyramid. Now, once I get that information, then what I need to do next is I need to calculate the area of my rectangular base. And I know to do that, we are going to multiply length times width, which is going to give us 11 times 10. The area of the rectangular base is 110 inches squared. From there, I just simply need to insert my numbers into the formula, 1/3 big B times H, where big B stands for the area of the rectangle that we calculated. So 1/3 times 110 times 16 for the height of the pyramid gives me 586.67 inches cubed. For the second one, the one in the middle, it has a little bit more to it than the first one did because our base of this pyramid is a triangle. So for our triangle, I have drawn out in the center here in green the base shape. And then I went in and identified the height of that triangle. I need the height because for the area of a triangle formula, it's 1/2 base times height. So I need to know what the actual height of that triangular base is. And think about this green triangle as being flat on the ground or flat on that bottom surface. So the first thing I'm going to do is to find the area of the triangle. So 1/2 times 12 times 7.5. And that gives me 45 millimeters squared. The height of my pyramid, if I take a look at my figure, the height of the pyramid is going to start at this top point, and then we're going to drop a perpendicular all the way down to the base. And you will also see here that, again, we have this right angle that is on the inside of our pyramid. Next, we're going to insert everything into our volume formula. So we're going to multiply 1/3 times big B, which is 45, times 10, the height of our pyramid. Once I multiply all of that together, we're going to get 150 millimeters cubed. Number 3 has a rectangular base. That rectangular base I've drawn out here in green and listed the length and the width. The height of the pyramid as given to me in the picture is 5 yards. First step is to find the area of the rectangular base. So we're going to multiply 21 times 9. That is going to give us 189 yards squared. Next, we're going to take that information, our big B, and the height of our pyramid, and we are going to insert it into our volume formula and multiply 1/3 times 189 times 5. That will give us a total of 315 yards cubed. Next up, you will see on your notes page a triangular pyramid. This time, the triangular pyramid has a right triangle for its base. It's not going to change anything that we do with our process, but we do need to figure out the height of the triangle that is the base, okay? So to do that, what we were actually looking for is we're looking for this segment right on the back side back here. Okay, so remember the green is basically what is sitting flat on the ground or on the bottom there. Okay, and so we need that because the 22.1 is the hypotenuse. It is not the height. A lot of times students get confused about height and they say, well, how do I know which one is the height? Well, remember that your height and your base of a triangle are always going to be connected to each other with that right angle. So that is one kind of key thing that you need to look for when you're looking for the height of a triangle and the base of a triangle to find the area. Using the Pythagorean theorem, we can see that we get a height of our triangle of 17.1. We're then going to take that 17.1 and use it in our area of a triangle formula. We're going to multiply 1/2 times 14 times 17.1. That is going to give us 119.7. That formula then goes back into our volume of a pyramid formula, and we are going to multiply the 1/3, the 119.7, and the 19 together to give us 758.1. Next up, we have another triangular pyramid, but this time we are going to have to do a little bit more work to figure out the height. So the triangular base that we get is an equilateral triangle. And so what I did here on this first screen triangle here is I drew out the triangle and then I dropped a perpendicular. This is going to be your height of that green triangle that is your base. Okay, so you may be like, well, which green triangle are we talking about? I don't know where that is. This is the green triangle right here on the bottom. So that is the triangle that we are looking at. Now, from here, we have to use the Pythagorean theorem to find the height, which is the 8.67. So if we take and do 5 squared plus h squared equals 10 squared, that is going to give us 8.67 as our height. I then am going to find the area of that triangle. So we're going to multiply 1/2 base, which is 10, times the height, which is 8.67. That is going to give us an area of that triangle, which is our big B value of 43.35 centimeters squared. We're then going to put that into our formula. And if I look back at my picture, the height of my pyramid is 16. Once we multiply all of that together, we're going to get 231.2 centimeters cubed. All right, next up we have a kind of a word problem or a real world problem here that says Caitlin must build a sand castle in the form of a square pyramid for a project as shown below. She bought 3 bags of sand, each containing 1,200 inches cubed of sand. Will she have enough sand to build the castle? So the first thing we're going to do is try to find the volume of the pyramid that she is going to try to build the castle. It does have a square base. So at the bottom here, we are simply figuring out the area of the square. When I figure that out, it gives me 625 inches squared. I'm then going to put that back into my volume formula, which is 1/3 big B times H. And then that is going to give me 3,750 inches cubed. Now, as for the sand, 1 bag of sand contains 1,200 inches cubed of sand. If she bought 3 of them, I'm going to multiply the 1,200 by 3 to get a total of 3,600 inches cubed of sand. If we compare the 3,750 and the 3,600, if we compare those two numbers, we realize that she will not have enough sand to build the castle, since the volume of the castle would be 3,750 and the volume of the sand total would be 3,600. She is 150 inches cubed short, so she will not have enough to build the sand castle.